This is the first discussion on heat and phase changes, what we've been working on the past 2 weeks or so in class. The first thing I'm going to review here is that we have 3 phases of matter. Those of you that did some research on plasma and Bose-Einstein condensate, you can read about those, but for the most part everything we deal with is solid, liquids, or gases, which is depicted here. Solid, here, liquid, here is the gas. So you can see there's a couple different characteristics of these. Gases are rigid, liquids have fluidity to them, and the gases fill the container completely with their particles. So phase changes is going from solid to a liquid, or solid to possibly a gas, or a liquid to a gas, or vice versa. So these changes occur between states of matter. Phase changes are a physical change, which means that there's no chemical change that occurs, and they are reversible, as we've seen. So during a phase change, heat energy is either absorbed or released. And so this was that Q value that we calculated. The Q value can be positive or negative, either one, depending on which direction you are going. Heat energy is released as molecules slow down and move closer together. Heat energy is absorbed when they speed up. So, like in the examples that we had with the energy graphs for the phase energy, that's why we had different bars for, if it was a solid, it was 1 bar. If it was a liquid, it was 2 bars. And if it was a gas, it was 4. That's what these 2 points are saying, is that as the heat energy is absorbed, the molecules speed up and expand, i.e. the hottest one and the fastest moving one is a gas. Types of phase changes you can see here. Vaporization is going from a liquid to a gas. Condensation is from a gas to a liquid. Freezing and melting you're familiar with. The 2 that are most unfamiliar to you are decomposition and sublimation. We don't really deal much with those because going from a solid to a gas or gas to a solid is really hard to do. Not very common changes. Melting is a phase change from a solid to a liquid. Molecules speed up, they move further apart. I think everyone's pretty familiar with that. Phase change from a liquid to a solid is freezing. So molecules slow down, they move closer together, and generally release heat. Vaporization, boiling. So this is a phase change from a liquid to a gas. It occurs at the boiling point. Molecules speed up when they make that jump from the liquid phase to the gas phase, and it takes absorption of heat energy for this to occur. Evaporation is also from a liquid to a gas, and this is where this is very similar to the boiling point, except molecules speed up, they move farther apart, they absorb heat energy. Most commonly, evaporation occurs when you're sweating. That's a very common occurrence. And so when the water that you sweat out of your body absorbs some energy from your body, that allows it to make that jump from a liquid to a gas. And that's why you cool down, because it's taking the heat from your body and transferring it to the water. Condensation is a phase change from a gas to a liquid. You most commonly see this on a glass of ice water in the warm summer day where it's humid out. Molecules slow down, they move closer together, and there's a release of heat energy in terms of the water as it makes its transition. Sublimation, this is one of the ones that we probably won't go too deep in with, but solid to a gas. It's very similar to the transition from solid to liquid or liquid to gas, but basically it makes both of those phase changes at one time. Usually occurs under certain pressure. Deposition is the opposite from gas to a solid. So here's that graph of the phase changes that we've been working with a lot. Notice the plateaus are where these phase changes occur, and that's the most important part. The slanted regions are the regions that have just a single phase. Melting and freezing of water. So again, the plateau is where that phase change occurs. And remember, we put down here time in minutes, but this could also be energy, because we need to add energy over time, like i.e. with a Bunsen burner. Melting and boiling points. Melting points, the temperature at which a solid changes to a liquid. So this is roughly 0 degrees Celsius for water. The boiling point is roughly 100 degrees Celsius for water. The freezing point.
The following students please report to the high school office immediately. Nicole Bartlett, Hannah Hartog, Mike Nelson, Mitch Nieders, Natasha Troback, Olivia Troback, Caitlin Zymitz. Please report to the high school office immediately.
The freezing point is the same as the melting point. So this is roughly 0 degrees Celsius as well. So here's the summary. Notice, this is the important part from this. You have solid water, liquid water, and water vapor. And so here's the transitions that occur: condensation, freezing, evaporation, melting. 80 calories is needed. Remember, that's the energy that's needed to make this transition work here, where it's 600 calories to make this transition work. So a lot more energy is required at this step over here. Okay, that concludes the first of the 2 videos. If you want to go on and watch more of the math examples, that will be posted below this video.